Hello, my name is Charlie Sands, and this is my Wi-Fi tracking system MYP personal project presentation for 2021. For my learning goal, I wanted to combine some skills I already had, like hardware hacking and software development, with some new skills that I always wanted to learn about, like project deployment and advanced computer networking. To that end, I designed this system, which allows me to track the approximate location of almost all the Wi-Fi enabled mobile devices in my school's cafeteria. It does this by listening to the signals that a mobile device transmits to the school's network when it talks to it. When it hears one of these signals, it transmits some information about it over my own Wi-Fi network to my server. My server takes this data and performs some mathematical operations and then sends it back over the network through a cellular uplink to my home network where my laptop can listen to these location information and display and analyze it. The mathematical process that allows this location to happen is called trilateration. Trilateration, as you can see by this diagram, is actually a rather simple concept in essence. It involves having three different wireless radios and an estimated distance from each one of the radios. This estimated distance can be determined through the signal strength of a signal coming from a mobile device. When a mobile device transmits a signal, each of the radios at known locations receive it, and they transmit an approximate distance to my server. My server then uses a algebraic operation that is not so different from this diagram here to figure out approximately where the three circles intersect, or where the device is in the room. In order to do this, however, I need some rather powerful wireless radios, which is where eBay comes in. I searched through eBay to find a good piece of hardware that would allow me to listen to these signals in the room. Eventually, I settled on the Cisco Meraki MR18 wireless access point, which was both affordable and had a radio that was powerful enough to listen to all the signals in the room. In addition to this, it's rather well documented, so it's pretty easy to hack. Once I had figured out that my project was actually feasible, I decided to set out some success criteria. For the function of my machine, I decided that it needs to be able to collect data from multiple different Wi-Fi signal capture devices and aggregate it to make accurate location measurements. For the quality, I said that all software for the machine it needs to be written in a way that's maintainable and will allow for future modifications by myself or by other people once I release the code under an open source license. For the specifications of the final system, I said that the machine needs to incorporate at least 3 separate data collection devices, because that's the minimum for trilateration. I said that the location estimates need to be within approximately 5 meters of the actual device. That way the location estimates can be considered useful. And finally, the machine needs to be stable enough to run for a substantial amount of time and tolerate the loss of its data collectors without catastrophically failing. The last part is especially important because I plan to set up my tracking machine inside a public place where people are prone to inadvertently damaging it by tripping over a cord or smacking into them. All this combined into my learning goal of to write software that facilitates the tracking of Wi-Fi enabled mobile devices in a room. In order to accomplish this learning goal, I needed to combine multiple ATL skills. The first of these ATL skills is research. I needed to research questions like, how do you effectively install and deploy a Linux server with custom software? And how do you write the software for that server? I also needed to research questions like, how can you use the JTAG debug interface to flash a wireless access point with custom firmware? These were all questions that were thoroughly documented online in papers and in books, and I didn't have too much trouble finding the answers to them. Not all questions were like this, however, and that's where the ATL skill of thinking comes in. There were many questions that I couldn't find answers to online or in books, and I needed to come up with solutions myself. Some of these questions I had to answer by myself were things like, what's the most effective way to architect software so that I can ensure that the software is fault tolerant? And what's the most effective way to flash 6 wireless access points with the same firmware? Is there any way to do it in batches to speed up the process? Once I had solved all these problems and built my machine, I had this. It was set up in the cafeteria of my high school, which you can see right here, and run during multiple lunch periods. You can see a time lapse of one of the lunch periods here. In the bottom left-hand corner, you can see much of the data that my device collected from the room. In the most bottom left photo, you can see a list of all the devices that it found and an approximate location for each one of them. In the photo next to it, you can see a unique web page that it generates for each device that it finds. It reiterates the approximate location in numbers, and it also shows a graph that shows the approximate location visually of the device in the room. Finally, in the topmost photo, you can see that my machine found almost 800 devices during one lunch period. That's about on par with what I would expect, considering that there are about 2,000 people that go to my school and there are 3 lunch periods. Once I had completed my project, I needed to reflect on it. First, I reflected on the function of my project. It uses modified Cisco Meraki MR18 wireless access points, running custom code to send information over a wireless network to a data aggregation server. This server uses the data to make location predictions and then sends them to my computer via an API. This works entirely as I intended it to, and it's up to the standards that I set at the beginning of my project. Next up was quality. I think I wavered more on this one. The quality of the majority of the project was up to my standards for what is maintainable and understandable code. However, due to some shipping delays on the Cisco Meraki MR18 wireless access points, parts of the project's code suffered a little. Mainly, the web front end could stand for some improvement. Before the open source release of the code, I'll need to clean this up so that the people who come after me and modify the project further will be able to understand it. Next, for the first specification, that is, the machine incorporates at least 3 separate data collection devices, I think I succeeded. There are 6 fully functional Cisco Meraki MR18 wireless access points serving as the data collection components of the machine. Each of them run my own custom code, and I'm happy with how they work. For the location estimates, I think I wavered again. My limited testing showed that the location tracking capabilities of my machine were within 3 to 8 meters of the actual location of my test device, a stock iPhone 5S. However, due to the time constraints caused by shipping delays of the MR18 access points, I didn't have enough time to test it as thoroughly as I wanted to. For this reason, I don't feel comfortable saying that all of my estimates were within 5 meters. That doesn't mean, however, that they were not. It just means that I don't know. Finally, regarding the stability, there was a silver lining to the shipping delays that I encountered. Although I didn't have time to work on the web front end, I could still improve the stability of my server code. This means that no matter what happens to any of the data collection devices, the server app will not crash. Once I had received the access points, I tested it by stopping one of the wireless access points abruptly and seeing how the server handled. The server was able to continue functioning and eventually even recover the device that had failed without any restarts, so I was very proud of that, and I think it was one of my areas of strength. For my overall evaluation, I think my project went well. One person said, "Charlie's project is a great example of how everyday technology can be modified and used to learn about our surroundings. There are many use cases for using Wi-Fi location information in an ethical manner. For example, in light of the pandemic, occupancy can be estimated to limit the number of people in a particular area of a building. Another example is to gain awareness about where people are in a building for safety and security purposes. Furthermore, organizations may be interested in understanding how foot traffic flows through the building. Some people are concerned about the information that is collected about them, but there are many valuable use cases that do not identify specific individuals." With that, I'd like to say that all of the supporting documentation and sources that I mentioned are available in the pages that are attached to this presentation. There's also some further detail about some parts of the presentation in case you are a little confused. Finally, I'd like to thank you for listening to my presentation and thank all the people, including my friends, my family, and my teachers, that helped me with this project. It would not have been possible without them. Thank you.